This is the lesson for section 6.6, solving radical equations. To solve a radical equation, an equation that contains a radical expression, or an expression with rational exponents, isolate the radical expression or expression with rational exponent and raise each side to a power that eliminates the radical or rational exponent. Then solve the resulting equation and always check your result to make sure it's valid in the original equation. Let's start with number 1. So we have the square root of x plus 13 minus 8 equals negative 2. We want to isolate the square root of x plus 13, so we'll add 8 to both sides. When we do that, we get the square root of x plus 13 equals positive 6. Then we will square both sides to remove the radical, and when we do that, we get x plus 13 equals 36 and x equals 23. And we want to get in the habit of checking that, and we do that by plugging back in for x. So 23 plus 13 is 36. The square root of 36 is 6, and 6 minus 8 equals negative 2, so it checks. Let's go to number 2. In number 2, we have the quantity 3y plus 1 raised to the 1/3 power plus 5 equals 0. So we want to isolate that rational exponent expression by subtracting 5 from each side. When we do that, we get the quantity 3y plus 1 raised to the 1/3 power equals negative 5. And we're going to raise both sides to the 3rd power, the reciprocal of our rational exponent, because we know 1/3 times 3 equals 1, and that will eliminate the rational exponent. So now we have the quantity 3y plus 1 equals negative 125. We'll subtract 1 from both sides. 3y equals negative 126, and divide both sides by 3. That gives us y equals negative 42. If we check that, 3 times negative 42 is negative 126. When we add 1, that's negative 125. When we raise that to the 1/3 power, which is taking the cube root, we get negative 5, and negative 5 plus 5 equals 0. So again, that checks. Number 3. This time our square root we need to get by itself by subtracting 4 from both sides. So we're going to have the square root of x plus 2 equals negative 3. Now, I want you to recognize something at this point, and that is the fact that we have a square root equal to a negative. It's okay to have an odd root to equal a negative, but not an even root like a square root. So this should raise the alarm that this is impossible. But often we overlook that and we go ahead and we just kind of not thinking, we go ahead and square both sides. And if you do that and solve, you would get x plus 2 equals 9 and x equals 7. Now if you check that, 7 plus 2 is 9, the square root of 9 is 3, and 4 plus 3 is 7, and 7 certainly doesn't equal 1, which should result in telling you that there isn't a solution. And if we, let me erase that. If we observed that ahead of time, we wouldn't need to even go that far, because when we get to this point, we want to recognize that's impossible and interpret it right off the bat. So you save yourself a little work if you're alert and recognize that before you go ahead and square both sides. But that's why you want to check your answers. Number 4, this time we have two radicals, but the good news is they're both already isolated because there aren't any additional terms on either side. So squaring both sides actually removes the radical, and we have the quantity 2t minus 7 equals t plus 2, and if we subtract t from both sides and add 7 to both sides, we get t equals 9. If we check, on the left, 2 times 9 is 18, 18 minus 7 is 11, we have the square root of 11 on the left, and then when we plug 9 in on the right, 9 plus 2 is 11, and we have the square root of 11 on the right side, so that also checks. Look at number 5. We have, again, two radicals. On the left, we have one of our radicals isolated. On the right, we can't isolate that radical, so we're going to always want to isolate at least one of our radicals. In this case, it's already done for us, so we'll go ahead and square both sides. On the left side, we get x minus 12. On the right side, you've got to be careful because you're really squaring a binomial, and you either need to do FOIL to get that product or the shortcut. The shortcut is what I prefer, so I square the first term, the 2, and I get 4, which is the same as 2 times 2 in FOIL. Then I take the product of my two terms. 2 times the negative square root of x is negative 2 times the square root of x, and that is both your outside and your inside product when you do FOIL, so I always double that, and I have minus 4 times the square root of x, and then I square the last term, which gives me a positive x. So the good news is I got rid of one radical, but I still have one radical remaining. So I get to repeat the process of isolating the remaining radical, and that means I'm going to subtract x from both sides. That cancels the x out. If I subtract the 4 from both sides, I'm going to have negative 16 equals negative 4 times the square root of x. And I can divide both sides by negative 4, which gives me 4 equals the square root of x. And now I've isolated my radical, so I can square both sides. And I am going to get 16 equals x. So let's check that. In my original equation, I'd have 16 minus 12 on the left, which gives me the square root of 4, which I know is 2. On the right side, when I plug 16 in under the radical, I'd have the square root of 16, which is 4, and I'd have 2 minus 4, which is negative 2, so that does not check, and they're not the same, so that means we have no solution. And anytime that occurs, we have what's called an extraneous solution, like we did up in number 3. It's an extra solution that unfortunately is not valid in the original equation. Number 6, last problem. So again, we have two radicals, but we don't have one isolated, so we're going to isolate typically the more complex one, which I would say is the square root of 2t plus 3. I will subtract the square root of 2t from both sides, and now I have one of my radicals isolated, so I'm going to square both sides, and that will allow me to get rid of the radical on the left. On the right, remember, I get to do FOIL, and so you can either do FOIL out in the margin or do the shortcut, my preference. 3 squared is 9. That's also the first product. And then the product of my two terms is negative 3 times the square root of 2t. And I'm going to double it but that is both your outside and your inside product. So I have negative 6 times the square root of 2t, and then I'm going to square the last term, and that gives me 2t. So now I need to isolate my remaining radical. I'll subtract 2t from both sides, and now I'll subtract 9 from both sides. So I have negative 6 equals negative 6 times the square root of 2t. I'll divide both sides by negative 6 and get 1 equals the square root of 2t. And now I can square again, and I get 1 equals 2t, which means t is equal to 1/2. If I check that, in my original equation, 2 times 1/2 is 1, 1 plus 3 is 4, the square root of 4 is 2, plus, in the second radical, 2 times 1/2 is 1, the square root of 1 is 1, so I end up having 2 plus 1 on the left, which is 3, and checks. So, the key is isolating a radical and raising it to a power to eliminate the radical or rational exponent. If it's an even root, you do need to be more careful for looking for extraneous solutions. And if there's more than one radical, isolate the more complex one and then repeat the process to isolate the second. And as always check for those extraneous extra solutions that are not valid in the original equation.